right, guys, welcome to week 3. We are almost halfway through this 6-week end of the year period, and we are going to be really getting into a super cool project this week from Robot Benchmark called Obstacle Avoidance. I just want to show you here what I've got in this section, and basically what I'm doing is I'm going through the obstacle avoidance help notes. So everything I'm saying here in this video, you'll be able to go back to this document and see what I'm talking about, okay, in written form. You can also go back and refer to the video if you like. Detailed documentation. This is a website where you can go to get really technical information about this whole Robot Benchmark online robotics platform. It's based off of what are called Webots, W-E-B-O-T-S, and this web page basically takes you there. It's very complex. You can also get there from one of the windows in the Robot Benchmark, and we'll take a look at that in a second. Most of you won't need to do that. And then here is the upload for for week 3 that you need to get in by Friday. You can be late if you want. I'm not marking anything off late, but this is where you're going to upload your code. There's some information there as well. This was a primer video that I made last week. You can take a look at this. It does have an example of my program, and tells you what I'm looking for. So let's go ahead and dive right into this. I'm going to bring us over to the actual obstacle avoidance. I'm going to bring us over here into the program. Let me show you how you're going to access that. So when you come into the Robot Benchmark, you can see that I'm not logged in right now. The reason I'm not logged in is because I don't want you to see my code. I want you just to see I just want to use the basic code that they provide. So once you come into this main page, you click on Start Programming this benchmark. And this is week 3. This is I believe it's the 3rd program on there in the Robot Benchmark. Takes a second for it to come up. And we're going to be looking at the window on the left that gives you all the information about this particular robot and about this particular project. I'm not going to get too deep into it. I want to just point a few things out for you. I really want to focus on how to use what's called the compass in this little video. So as this thing is loading, well, let me just pause the video here. I'll be right back. Okay, we're back. Sometimes it takes a while for this particular program to load. Okay, so here we're going to look at the overview, metrics, instructions, and explanations here. And then talk about the compass in particular, and also something about the code, a few things about the code that are going to be very important. So first of all, you notice here that this overview, this particular program is based on a real robot called the Thymeo 2. And you can actually look that up and you can find the real robot. And that sometimes is pretty helpful. It says here the goal for this is for the robot to cross the room as fast as possible. We are not going to use that as our goal, okay? That is not our goal. I do want you to speed the robot up because it goes rather slow in the base program. I do expect you to speed it up, but your object is not to get it to go as fast as possible. You may get lucky and just have the thing go straight through without even touching anything. What I want you to do is I want you to, number one, I want you to have it avoid obstacles, which is what it does naturally. But I want you I want you to use what's called the compass. And the compass allows the robot to actually go straight ahead. If you don't use the compass, what happens is, let me just go ahead and start this. And this is just the basic program. I'll start it, and maybe it'll happen. What can happen if you're not using the compass? So you can see that it's. Let me go ahead and close this. So it's going through. It's going super slow. And you can see that it's sensing the parts. It's sensing them, and then it's moving around the parts. Now it hit that block, and the reason it hit it, there's different reasons, but you want to try to program your robot so it doesn't hit the block. Okay, let's see. It's not gonna. I don't think it's gonna do. Oh, maybe it will. So watch what happens here. It turns left. It turns left. It turns left. Yeah, it did. So now look where it's going. It's heading off into the distance on the left. What I want this to do is I want this robot to turn toward the north, which is straight ahead, and that way it's going to cross the finish line. This is taking forever because it's going to go all the way across diagonally. That's not what I want. if you look here at the obstacle avoidance primer, and I'm not going to play it because there's sound on it and I don't want it to override me now. If you click on this, it'll show you my robot and how my robot reacts to obstacles. It always turns back to the north. That is what I want you to do. Also, what I'm looking for in this particular in this project is I want you to, sometimes your robot's going to encounter a couple of different obstacles right in front of it and it's going to get stuck. So I want you to, it's not going to be enough to turn left or right. So what I want you to do is I want you to have the thing back up and then turn left or right to avoid that whole obstacle. Okay, so you're going to want to get out of a jam. So I'm looking for two things. Number one, I want you to head north and use the compass. Number two, I want you to avoid the jam. And actually, you can reverse those. Some of you are not going to be able to get the compass to work, but you should be able to, just with the programming you know how to do, you should be able to get the wheels to back up and then to turn and avoid that obstacle if it senses two things in front of it. Okay? Notice that I clicked off of this eye. This eye toggles the information off and on. Okay? So that's the overview. Let's look at the metrics. Okay, the metrics, it says that it's based on this time. I'm not worried about time. Don't worry at all about the time. Just worry about having a robust program that can get around multiple obstacles and one that uses the compass to head north whenever it can. Okay? All right, and this gives you some information about how the program actually works. You can go ahead and read that. All right, instructions. How to improve the time. This is very interesting. I do want you to speed up the robot. You'll notice that it says here that it uses its sensors in the front. There's 5 sensors in the front of this thing. There's a left, a right, a mid-left, a mid-right, and a middle sensor. Okay? And it uses the values of those sensors to control the speed of the wheels. And you'll see that when I look at the program here in a few minutes. All right? Down here is where it mentions that if you don't know the absolute direction of travel, it's possible for the robot to get disorientated and fail to reach the other side. You saw that right here. It looks like it's going off in that direction because it's not using a compass. Here is the information about the compass. We'll get more into that in a minute. The documentation that I mentioned in the beginning, you see right here where it says full documentation. I'm going to click on this and show you what this looks like. I have this link on the in week 3. So this is detailed information about Weebots, the Weebots reference manual, and it's very complicated. Okay, if you come over here to Python, it shows you the different codes for Python. Okay, you see that self right there? You should know what that means if you did the Code Academy. As we come down here, it gives us information about the compass, pretty complicated, and then it tells us how we can actually get a heading or a bearing. You don't need to do this in order to make the compass work. I did not use this information. You will not need this information because I'm going to give you some hints that will, I've kind of done the work for you. It's a little bit tricky. All right, but anyway, this website doesn't just have information about the compass. Look at all the different types of sensors, all the situations, all the different the motors, everything about this program is down here, and you can get detailed information about it. It's very complicated. It's very involved. But those of you who want to go further, feel free to reference this page and go for it. All right, back to this. So we'll get back to this in a second, to the compass. All right, let's look at the explanations here. This is kind of cool. This talks about that this particular robot is based off this Brandenburg vehicle. And you can look this up and read it. It's pretty interesting. Basically what it is that the sensory inputs from the sensors, the values of the sensors, control the speeds of the motor. Okay? So as we get into this, you'll see what that means, and you can do some more research on your own if you'd like to read about that, but that's just what it's saying. Okay, let's go ahead and go to, I'm going to rewind this. Let's go ahead and go to the actual program and take a look at it, okay? All right, I'm going to right click and say Edit Controller. This is the base program. If I just run this, remember whenever you make changes, you make the change, you click Rewind and Run. Okay, that's how you do it. All right, let's take a look here at this code. Notice here that we're importing robot, the class and all the different definitions and functions that are related to robot are going to allow us to use some of these different, this left motor, right motor. See the robot.get motor? Okay, that should look familiar, right? We worked with that kind of a thing in with these classes when we did Unit 11 last week. So now you can kind of see, if you look at this program, you can see why I had you do that Unit 11. Because now this doesn't look so bad, it doesn't look so scary, does it? Because you just see some variables, you see some functions, some classes, and passing variables from other functions into here, and it's complicated, but it's not so far out there that you have no idea what's going on. All right, I want to talk just for a second about some of these codes. So this time step, this is very important. This time step, you don't want to mess with this. Okay, this has to be in your program. Do not mess with this at all. And basically what this does, notice this is a variable time step, and what it's doing, it's syncing the robot with the basic time step of the world. So there's a couple different things going on here. The physics of the world, you know, the blocks moving around, the manipulating the board, looking around left and right, that is all based on the world. But then you've got the things that are happening on the robot. You've got the wheels spinning, you've got the sensors making readings and things like that. This time step syncs the robot and how often it reads the sensors and actually turns the wheels. It syncs it to the time step of the world. It's complicated. I tried to mess with this a little bit to try to speed things up, and it didn't work. It was very messy. Don't mess with this. You will notice that, like down here, notice here this time step variable is passed along to here. So in order to enable the sensors, outer left sensor dot enable, and then this time step function, which is this, right? This is an integer. This value is passed into here. So and typically the value for this, just so you know, the value for this is 16 milliseconds. So every 16 milliseconds, the computer, the program is getting a reading from the world and reading the sensor every 16 milliseconds. So every second, what is that? About 60? About 60 times a second, it's looking at the situation and reading it and doing computations. So that's what that means. It's complicated. Don't worry about it. It's a variable that's an integer of 16 milliseconds, and it's getting passed into the sensors to enable them to sync them up with the physics that are happening in this virtual world. Okay, down here. This is these are important. This max motor velocity is set for 9.53. That's a value that you'd have to look up to see what the unit of that is. Okay, I'm not going to give that to you. However, you don't want to change this. Okay, do not change this value. And you'll see down here later on that the velocity is related to this max motor velocity. There's other ways you can change your velocity. Don't change it here. Okay, this is a calibration constant. You will be changing this. You can change this value to make your motors go faster. Okay, so this value do not change. This value you will change to make your motor go faster. Okay, here we have the left and right motor. There's only two motors on this robot, left and right motor. Down here, the sensors are being, it's bringing the sensors into the program. So here are the variables for the sensors, and you can see there's 5 of them. Outer left, center, center right, outer right. Okay, so there we've got our sensors coming in. This is enabling the sensors. Notice again, it's with the time step of 16 milliseconds. So the sensors are brought in, the sensors are enabled. Okay, now down here, this disable motor PID, don't worry about that, but don't change that. Here, set ideal motor velocity. So there's this value initial velocity, and it's being set to 0.7 times the maximum motor velocity. What's the maximum motor velocity? Well, we saw it up here, didn't we? Here's the maximum motor velocity. So if for some reason you wanted to change this, you could change this by changing this value right here. Okay? Don't change it here. If you want to change it for some reason, change it here. All right, let's take a look down here now. Let's set the initial velocity of the left and right wheels. So you have to tell the the computer how fast the wheels are going to spin. This is saying, all right, the left motor set velocity is going to be set to the initial velocity. And the initial velocity is right here. So this variable initial velocity is 0.7 times the maximum motor velocity. And that's going to be the velocity that's going to be the initial velocity, is 0.7 times that, okay? So unless we were to change the velocity somehow, this would be the value of how fast the motor would spin. Okay? Right here. Okay, now let's take a look at this part of the program here. This is where it really starts to happen, right? This is where this is the while loop. This was all setting the variables up. This is now where things are happening. So it says while robot time step is not equal to -1. Okay, it's always going to be greater than -1, right? It's never going to be -1 because it starts at 0 and it progresses at 16 milliseconds. Every 16th of a millisecond it indexes. So this is just basically like saying true, right? So while the robot time step is not equal to -1, do these things. And the first thing it's going to do is going to read the value from the sensors. Now, notice here, it's setting these variables. Now, these variables, outer left sensor value, okay, so that's a variable. It's equal to the reading, and notice this get value. This is kind of how you get values in this Weebot environment. So it's going to take the value of that outer sensor, and look here, it's going to divide it by the calibration constant. So that's going to give you some number. Now it's going to be to your benefit that as you run this program, you're going to be inputting code in here. Okay, you're not just going to be changing things. You're going to be putting new code in. You're probably going to have if statements. You're going to be, you might even have while loops, things like that, depending on how you write your program. But one thing you definitely want to do to get a feel for what these values are is you want to print these variables. You're going to want to print these variables and print them out to see what they are as the robot runs. And the way that you would see it is you would say print, right? Print the variable. And down here, by clicking on this box here, this is where you see the console. Okay? So you can toggle that on and off. I highly recommend that you print some of these variables so you can see what their values are so you know what's going on. And that's going to help you as you write your program. Okay? So there's your console. When you run your robot, when you run it, things are going to be showing up here. Now, it doesn't show much because we're not printing anything out. But if you put print statements in here, they would print here. Okay? All right. So notice that our values are basically getting the values of the 5 sensors and dividing by the calibration constant. Now, here's where it gets kind of strange, but I don't think it's beyond you. Notice here that we're setting the motor. Okay? Now look here. It says, set the wheel velocities based on the sensor values. Prefer right turns if the center sensor is triggered. Okay, now look what it does. It's saying, all right, the motor velocity, we're going to set the motor velocity to the initial velocity minus this value here, the center right sensor plus the outer right sensor divided by 2. That's the average, isn't it? Okay, they're going to take whatever the initial velocity is and subtract the average of these sensor values. Now, to change the speed, you might be able to change this denominator. You want to play around with that and see what happens when you change that denominator. Left motor sensor, right motor sensor. Now notice it says here, it says that it prefers right turns. What that means is, and that's this right here, they're subtracting, this is the center left and the outer left sensor, the average value of that. But now it's also subtracting the central sensor value. Now let's look at what's going on here. If in this case, if the center sensor has a value, okay, if there's nothing in front of it, it's going to be 0, right? If there's nothing, if the sensor values are 0, what's the value of the velocity going to be? It's going to be the initial velocity, isn't it? If there is no sensor reading, it's going to be just whatever the initial velocity is. And here we set the initial velocity to right here, the initial velocity is 0.7 times the max velocity. So one way we could speed this up is just to change this to the maximum velocity, right? Get rid of that 0.07 and see what happens. You're going to want to play with this number right here, okay? Now, if the let's say the right sensor is triggered, right? So in other words, it's the robot sees something on its right two sensors. Here are the 5 sensors. One, let me rotate this around here. Let me rotate this so you can see it. Oh, I should know what I'm doing on this. Here we go. So if I rotate this, you can, come on. There it is. There's the 5 sensors. 1, 2, 3, 4, 5. Okay? So these sensors are getting readings from the field. Hang on a second. Let me just play this. Oh, no, I don't want that. Okay. So those 5 sensors, let's say that these, let's say that these 2 sensors, let me resize this window here. Okay, so let's say that these 2 sensors sense that there's an object. What does the code say that it's going to happen? So those are the left sensors. So if the left sensor is activated, right? Center left sensor plus the outer left sensor. So if those 2 sensors are activated, it's going to take the initial velocity and it's going to subtract that. So what's going to happen to the right motor? The right motor is going to slow down. If the right motor slows down, what happens? This turns to the right. You see that? And the same way on the other one. If the right sensor is activated, the left motor slows down and it turns to the left. Okay, so by slowing down the speeds of the motors, you're able to get it to turn left or right. Okay, so I think that that is good information. Now let's talk about this. Let's talk about this compass. Okay, and then we're almost done, and you'll be able to get busy modifying your code. All right. If you look at the compass right here, it says to use the compass, you have to import the compass module. Well, where do you think you'd put that? Right here, right? You'd have to put this, so you just copy this here, like this, copy, and over here, you'll paste it. And make sure that it's, make sure that this is all spaced out properly, okay? So, I'm going to bring that in there. Now, to get the robot compass device, compass equals robot.getCompass compass. Well, look here, it's just like this. Robot.getDistance sensor, right? So down here, I can put it right here. I'm going to go ahead and I'm going to copy this, and I'm going to paste it right here. And because I'm getting the compass, right? And you want to bring that back. Okay, so now I'm getting the compass. Now the compass is there. Now, what else do you have to do? You have to enable the compass. Here's where you enable it, all right? This is and notice it's enabling it with the same time step as the sensors. So down here, I'll just put it right here. I'll post this here. All right. All right, now I've just enabled my compass. Now, how do I use the compass? Okay, to use the compass, it's right. This is what you need to do. You need to use this values. Now I'm going to put this here. I'm going to bring this in so I can refer to it. Okay, and we'll just put it right down here. Now this is probably going to have to be. This is where you're going to get that value, right? It's where you're actually going to get the value. This is going to have to be in here somewhere. I'm just putting it in here for now. I'm just putting it here for now so I can refer to it, okay? But you are going to need to put this, you're going to need to put this get value in your while loop. Otherwise, it'll only get it one time and won't get it ever again. You need to be continually getting the values of your sensors and of your compass. Okay, now I want to give you a couple of hints, all right? And these hints can be found. I'm going to go ahead and open this document that I'm reading from. Here are your notes. The hints are below the compass value. Okay, so I have all this written out. Okay, this is here for you. I'm just kind of following this. here are the hints for the compasses, okay? All right, number one, when you get the value of this compass, the compass, this get values, it is a list. And the list contains 3 floating numbers that actually describe a position, X, Y, and Z. So we don't care about the Y value, okay? The Y value is the elevation, and we are on the ground. So we're not going to worry about the elevation. We're worried about the X. The plane of the floor is the XZ axis, okay? So the XZ axis, if we look here, this direction is X. This direction is Z. And up, okay, up, the elevation is Y. The way that this is laid out, is as a position vector X, Y, Z. So if I'm interested in the direction in front of me, which one of these values am I going to be interested in? Well, I'm going to be interested in the value of the X vector. Regardless of what the Y will be 0, won't it? Because the elevation is 0. And as the robot turns left and right, the Z value would also be changing, okay, as with the X value. We don't care about the Z value. We only care about the X value because we want as we start turning left and right, we want to turn the robot back based on that X value. Well, the way that you get that value is right here. Remember how to get the value of a particular item in a list? We would use values 0. That is the number that's inside of that list. Okay? So you will use the value of the first term in the list, values bracket 0, because the x-axis is up and down on the view screen. Okay? You're going to want to use that x value. Now, what is that x value? You need to print it. You need to print it and watch it as the robot's turning left and right so you can get an idea of what that value is. Okay? That's going to be very important. All right, that's hint number 1. Hint number 2. Well, I just gave it to you. It'll be useful to print out the value of the compass value. So when you print that out, you'll be able then to use that value in an if statement, right? So if the compass value is less than this or greater than that, well, you need maybe to speed up the wheel on the left side or the right side to return back to a northerly direction. Okay, guys, I know that's a lot. I know some of you are scratching your head. You may need to watch this video again. What I would do if I were you, I'd start playing around with these. The first thing I would do is I would start playing around with this distance constant and see how it affects the running of the basic program. Change this to 300, change it to 250, change it to 400, see what it does. Okay. Next, I would start to try to speed it up a little bit. Okay, try to speed up the value of this. Change this 0.7 to a couple things. Change these values down here. Change these values here to different numbers so that this isn't quite a big a penalty when it sees the sensor value. Okay, and then you're going to want to try to come up with I would come up with a code to avoid a situation when I got 2 things in front of me. Okay, if let's say you had like 3 obstacles in front of you, how would you've got the values of the sensors, right? And you're going to know what those values are. So what if you did something and said, okay, if sensor value of the left is greater than this, and the sensor value of the middle is greater than this, and the sensor value of the right is greater than this, well, what would you want to do if you're in a car and you came up to an obstacle? You'd want to back up, turn left or right, and then go around, maybe make a sweeping turn around that obstacle. So that's what you're going to have to do. Okay? Let me go ahead and run this one more time. This is just the basic code, and see if I can just wrap this up. I know you guys are going to do well. You're going to probably spend the full 5 hours this week, if not more, trying to work on this to get it to work right. There, it saw it turned left. It saw it turned right. It turned right. Okay, now see, it hit it. Why did it hit it? Well, maybe it's going too fast. Maybe it was going too fast at that particular point. You have to be careful. I'm going to go ahead and keep playing it. Okay, it's going off to the side. And it's just going to go off forever. Now see, this is where if you had your compass, it would roll and go back toward the line. Okay, and you'd be able to do it a lot faster. All right, guys. Work hard on this. I know you can do it. Feel free to ask questions. Send me messages. If you need some immediate help, send me a text message on my phone. And I look forward to working with you guys this week to get this happening. All right. Have a great time. Bye.